let's understand about first thing, what is a matrix? Okay, now because this chapter is entirely about matrices, types of matrices, that matrices, this matrices. So first and foremost, what is a matrix? So to understand that, now see, very simple explanation of understanding what is a matrix is that anything which you can arrange in terms of rows and columns, that is basically a matrix. Okay, anything like a table you have rows and columns, that is a matrix. So anything which you can represent in terms of rows and columns, that is basically a matrix. Okay, I'll give you a simple example. Say we are talking about work done by different people. Okay, now let's say I can say that we have men and we have women. Okay, and say the number of hours they work. Okay, number of hours. Okay, say this is 10 hours, say this is 9 hours. Something like this. Fine. Or next thing, number of hours. So this is given to you. Correct. And say the distance for work. Okay, this is distance for work. Let's say the distance of work, let's say this is maybe 10 kilometers and say this is say 8 kilometers. Something like this. Now what we are looking at is we are looking at in a way of arranging things, correct? Whatever might be the data, however might be the data, but you are talking about arrangement of data, correct? Now here this is what we call as a matrix, because if you look at this, we are arranging in terms of rows and columns, correct? So here the first and foremost, this is going to be a row. See, this is a row. Okay. Then another one is a column. See, this is what we call as a column. So any matrix you take, we have rows and we have columns. So here we have 2 rows and 2 columns, correct? Now, see, once you understand that what is a matrix, it's a rectangular arrangement of numbers, or it's an arrangement of data, correct? Now let's try to understand where matrices are used. Okay, let's start with the most basic thing, that is representation as a table, like the example what you're seeing right here. So that example is about how you can represent the data in terms of table. That's a matrix. Okay, now apart from that, practically where we are going to use. One simple example, and which is a very most effective example, is in the field of computer science. See, in computer science, there is a topic called as array. Array is nothing but set of numbers. Okay, so set of numbers. Now, arrays are basically matrices, one type of matrix, that's all. Okay, so computer science, we use matrices. Second, in the field of vectors, we use matrices. Vectors and matrices, they are interchangeable. They are pretty much one and the same. Vectors is one way of representing. Matrices are another way of representing. That's all. Okay, there is not much of a difference between these two. So in physics, we use this. Okay, now along with that, in this one also, in computer science field itself, arrays, when I told, it's mostly used for programming. Apart from that, we also use these matrices in arrangement of the disks within the computer. So matrices, they have a lot of practical use. Okay, lots and lots of practical applications are there from matrices. Now that you have understood what is a matrix and how we represent a matrix, in terms of rows and columns, now let's understand a very important parameter which defines a matrix. Okay, which defines a matrix. So that parameter is what we call as order of a matrix. Order of a matrix. A very, very, very important parameter is order. Now, without an order, a matrix does not even exist. I would say that order and matrix, they go hand in hand. If you have a matrix, you need to have an order. If you have an order, that means you need to have a matrix. So one will not exist without the other. Alright. Now what we mean by order of a matrix? If you look at the example what we have. Now you have 2 rows, 2 columns, correct? Suppose say I am going to take another example. Okay, very similar to this one. Another example. Let's say I'll take the score of in a test. Assume that we are looking at 3 students and scores of those 3 students in 2 subjects. Okay, let's say we have 2 subjects. Let's say math and say physics. We have 2 subjects and say we are taking at 3 students. Let's say the 3 students are A, B and C. Okay. Now A scores let's say 80 in math and say 75 in physics. B scores 93 in math and say 97 in physics. And C scores let's say 81 in math and say 72 in physics. Now basically it's just numbers which are represented in a rectangular form, correct? Now look at this and understand how many rows and columns are there. See, every horizontal line is a row, correct? That means this is one row. Likewise, the second row, third row. So what we have 3 rows. 3 rows are there. And that's next look at the column. So in this, math is one column, physics is one more column. So there are 2 columns, right? So we have 2 columns. Now whenever we write order, we write it as row cross column or 3 cross 2. So keep this in mind. Row comes first, column comes next. This is what we call as an ordered pair. So always it is row into column, never it is column into row. Like in coordinate geometry, it's always x comma y, abscissa comma ordinate. Likewise, in a matrix, it's always row and column. It's never column into row. Now what you see here, that 3 cross 2, it's not 3 into 2. We don't call it as 3 into 2. You are not multiplying here. You are representing the matrix. So you don't call it as 3 into 2. We call it as 3 cross 2. So 3 cross 2 matrix will have 3 rows, 2 columns. Okay, so here you have 3 cross 2. So in general, a matrix A will have an order of m cross n. Whenever we have m cross n, m represents the number of rows, n represents the number of columns. M cross n. Like 3 cross 2. 3 cross 2 represents 3 rows, 2 columns. Like in this example, see there are 2 rows in the first example. 2 rows and 2 columns. So the order becomes 2 cross 2. Fair enough? This is what we mean by order of a matrix. Clear? Now, since you understood what is a matrix and what is the order of a matrix, next we talk about equality of matrices. So here we are talking about 2 or 3 matrices. Generally we talk about 2 matrices. Clear? So let's look at another example as to what is an equality of matrices. When we talk about equality of matrices, let me give you an example and explain what it is. Suppose say we have a 2 cross 2 matrix. 2 cross 2 meaning 2 rows, 2 columns, correct? So I'll say that matrix A is equal to say 1, 2, 5, 7. Okay, 1, 2, 5, 7 is matrix. Then I'll give you another matrix. Say matrix B is equal to A, B, C, D. This is also 2 cross 2 matrix. Remember, this is 2 cross 2. This is also 2 cross 2. Both are of the same order. Now, suppose if I tell you that matrix A is equal to matrix B. That means you have 1, 2, 5, 7 is equal to A, B, C, D. Very easy. Okay, now whenever you have a problem like this, Remember, the corresponding elements are equal. In the sense, see, when you see that 1 here, see this 1, this element is first row, first column element, correct? This is the first row and this is the first column. So first row, first column element is 1. Now, corresponding to 1 on the RHS, the first row and the first column element is what? A, right? So what you have is 1 is equal to A. The corresponding elements will be equal. You cannot just randomly equate one to another. Only the corresponding elements are equal. So 1 is equal to A, 2 is equal to B, 5 is equal to C, 7 is equal to D. Now this is what we call as equality of matrices. Now for this, don't you think one very important condition is that the order of the matrices should be the same. If the order is not the same, then you won't be able to equate and get the value. Always it is that it should be, must and should be, that the order of the matrices should be the same. Then you can equate the corresponding elements and whatever unknown values you have, you can calculate what it is. Fair enough? Now this concept is what we call as equality of matrices. So in this you learnt what is a matrix, you learnt what is the order of a matrix, and you also learnt what we mean by equality of matrices, correct? So in the next video, you will understand few concepts of matrices such as how to build a matrix and all those things, and then you will see that further concepts of matrices will be discussed in the couple of videos after this.